If you're making a action-based combat system, you're probably going to want to have something like this, the weapon trails, just to have something that feels like the more traditional smear frames you would see in a lot of animation. So today we're going to build a very simple system, a emitter that's going to let you do that on a bunch of different weapons very, very easily and quickly. Now, first and foremost, we're going to make a blueprint class here. Let's just make an actor, and that will be our base weapon class. And in there, we're going to, for now, just add a simple static mesh. And we'll need to make a mesh real quick. If you have a mesh of your own, like a sword or whatever, you can just put that in here. I don't have anything ready at the moment. So what we'll do is I'll real quick go into modeling mode. I'll put down a cylinder, make the radius very thin, and that will do nicely as our stand-in for a sword, because that automatically makes a static mesh as well. So we can put in that static mesh here, and now we have this mesh as our sword. Next up, we'll go into this static mesh, so we'll open up the mesh itself, and we'll open up the socket manager. We're going to put in two sockets, one at the bottom of where we want the weapon trail to start, and one at the top where we want the weapon trail to end. So let's call this top socket, and we'll put that all the way up on the top of our weapon. And then we'll make a bottom socket, and we won't actually put that all the way on the bottom, we'll put that somewhere here. That way we can pretend like this is the sword handle for the time being. Now, back in our blueprint, we're going to go into the event graph on begin play. You can also do it in the construction script theoretically, but let's do this in begin play. We're going to give values to two variables, and those will be our top position, which will be a vector, and then we'll also make a bottom position, which will also be a vector. So we're going to set both of those values. And what are we going to set those to? Well, we're going to set those to those sockets on the static mesh. So we'll get socket's location, and we need to put in the socket's name. The best way to do that is to literally just go over here and copy it and paste it in. And that will be the, I think that was the top socket, right? That is the top socket. And then we'll do the exact same thing for the bottom socket. So we'll connect it up to the static mesh. We copy over the bottom socket's name. And now when the game starts, we will have a variable which stores the location for both the top socket and the bottom socket, which we can use to very easily change our particle emitter that we're going to make in a moment to always fit with whatever weapon we are using. Actually, let's make this into a custom event, set socket locations. That way we can also change it on runtime. So event begin play will just run the set socket locations event. So let's make a Niagara system, and we'll do that just in the root of the content folder here. We'll make a Niagara system. We'll just make a new system that is entirely empty. And we'll call this something like FX weapon trail. Opening that up, we'll need to add our first emitter here. So let's add an emitter, and we're going to add a empty emitter. And in the emitter update, we're going to add a spawn per frame. We'll dismiss the note that it gives us and change the sprite renderer. We're going to actually delete that one, and instead we will need a ribbon renderer because we're going to be rendering a ribbon. The trail will be a flat plane that will follow our weapon. It won't be a particle like a sprite. Then here in initialize particle, we're going to come over to the ribbon attributes, and we're going to change the ribbon mode from unset to being direct set, and we're going to set that to a variable. So coming over to the left hand side here, we're going to add a new user exposed variable, make new, common, we'll make that a float, and we'll call that ribbon width. And that will be the width of our ribbon. So we can just say, set that to whatever ribbon width we put into this particle system. This gives us now a variable that we can put in through Blueprint that will influence the width of the particle, which of course we're going to calculate based on those two positions we put in before. So now that we have that all set up, what we can do is we'll add a Niagara particle system component here, which we can parent to the static mesh. It doesn't really matter, the static mesh itself isn't going to animate, but we'll parent it to there, why not? And that will get the FX weapon trail system by default, if that's the only thing in your project. Otherwise you might have to manually set it. And we're going to set the float parameter with the name. Again, the best way to do this is just to go in, copy the name, and go back to place it in. Do be aware though that there's 2 set float parameter nodes that you could potentially get, and you want to get the one that targets the FX system. You also have a set float parameter that is for a audio component. For some reason that also comes up when you try to get it from your particle system here. You want to use the particle system set float parameter instead. And we will get the top position minus the bottom position, and from there we will get the length of the vector, and that will be our in float, which we will hook up to the end of the set socket location here to that event. So now when we set the socket location, it's going to calculate the top position, the bottom position, it's going to subtract those from each other, get the length, which is just the x plus the y plus the z, and it's going to set the float parameter for our ribbon width to that result. We also want to use the output from that subtraction to make rotation from z. That just makes sure that things will be lined up along the, well, for lack of a better term, blade, and not perpendicular to it or anything like that. And we'll use that to set the world rotation for our particle system. And as the very last thing we need to do is we need to set the world location of weapon trail to being our top position plus our bottom position divided by 2. So the average between our top and our bottom position. So we first add them together and then we simply divide by converting the pin to a float to 2 and then setting that as our new location. Then coming down into the ribbon renderer in UV0 settings, you want to set that to tiled by distance instead of non-uniform scale. And the ribbon facing mode should be direct set, and the ribbon facing vector should be system z-axis. So that's just simply system z-axis. Then the facing mode should go from screen to custom side vector in order for that to have effect. And now, if we play the game and I go into F8 and I move this thing around, you'll be able to see that it has this little trail behind it. Of course, it's way too long, and it's actually the wrong way around because it's going from transparent to opaque instead of from opaque to transparent. And we're going to go into the initialized particle here and set the lifetime to something like 0.4 instead. So first things first, in initialized particle, set the lifetime to something like 0.4 instead of the original 5 seconds that it lives. And then we're going to make a quick material to make it look a little bit better, because otherwise you're going to have a very boring smear frame anyway. So let's make a quick material for that. So we're going to make a material, call that something like material smear frames. We'll do a few things here. First and foremost, add a color. We'll just make this a gray color for now. And in my case, I do like to multiply that by a certain bit just to have it be a little bit more emissive, right? Because this is going to go into the emissive color, especially with lumen. That looks really, really good. Then the blending mode, we're going to change from opaque to being masked. That way we unlock the opacity mask here, and we're going to use dithering temporal anti-aliasing for that. And we'll use some particle inputs here. So first and foremost, we'll use the particle relative time, which is just a particle's age in a value from 0 to 1. And we will use that to interpolate something with a noise texture. So let's add a texture sampler, and we'll change the texture to the built-in purulent noise that Unreal provides us with. For the UVs, we'll use a texture coordinate node to make it tile a little bit differently because we want to stretch this out a little. I personally used 0.2 and 1 for the tiling. Pulling out of that, we're going to subtract a little bit from that. Quite a lot, in fact, because we want this to mostly be opaque. Since what we're going to do is we're going to add to that. Since this is going into the threshold, we want the threshold to keep increasing. And eventually that threshold will be beyond 1 and everything will have faded away. We'll add a 1 minus x from the particle time to the output from our material here. And just to make things look a little bit better, we'll add some cheap contrast with a simple value of 1. Putting that into the alpha threshold. And now we can see we start having this little smear frame look to it. And it really is as easy as that. So now we can put that material into our smear frame particle system here. And now if we move this thing around, we can see we have some proper smear frames. It looks a little weird with the outlines around it. So what we'll do instead here is real quick, I'll add a child actor component to our player. We'll make that the weapon and we'll put that in the one of the hands. And with a little bit of fiddling around, I hope I have it orientated in the right direction. We can scale this down a little bit and now we can pretend like this is a sword. And now we can see walking around, we do seem to have it maybe in the wrong direction. But our weapon has smear frames wherever we move it to. You can of course enable and disable the particle system mid-attack and that kind of stuff, but it's a little beyond what we're doing here. Today, we've made the particle system, we've made the blueprint, we've made the material, and now we have a basic setup that you can make into what you saw in the beginning of the video. So if you want to download this project file to play around with it, to check out the material or the particle system, you can do so in the description down below to my Patreon. There's a link there that you can download the entire project file with all the assets included. And a very big thank you to all of my Patreons. You can see them on screen right now. If you want to help out supporting the channel, there's a link down below in the description to the Patreon page. And a special thanks to my Cave Digger tier Patreons, Sir J. Thomas,